Hi guys, clip 672. So this is the second clip on product rule for counting. So just a reminder that to get the number of combinations of m and n values, you would do m times n. So let's say you've got 4 of one thing and 3 of another. That means it's 4 times 3, which is 12 different ways. Now these questions are slightly more difficult because they've got an extra level in them. You've got to be really careful reading the question. So, if there are 7 sandwich types and 6 crisp 4 drinks in a meal deal, where you can buy a sandwich and crisps or a drink, okay, so it's one of those two, how many different combinations of meal deal are there? Okay, so there's 7 different sandwich types, and then you can have either crisps or a drink. So how many different ways are there of crisps or a drink? Right, there's 10 different things you could have. Product rule says you times them together. That means there's 70 different meal deals. So just be careful, these are grouped together because you can have one or the other. Right, next one. If I forget my pin number, but no, the first is a factor of 10, and the 4-digit number is divisible by 5. How many different 4-digit numbers could there be? Okay, so it's 1, 2, 3, 4 digits. The first one's a factor of 10. So what can it be? Well, factor of 10, it can be between 0 and 9. So factors of 10 would be 1, 2, 3 doesn't, 4 doesn't, 5 does, 6, 7, 8, 9, 10. 5 times 2 is 10, so you can't go anything above. So there's 3 different possibilities there. What else does it say? It's 4 digits, we've got that, and divisible by 5. So to be divisible by 5, this end one has to be 0 or 5. So there's only 2 choices. Now the other 2 can be anything between 0 and 9, which there are 10 choices for each. And then you would times it together because that's the product rule. So 3 times 10 times 10 times 2. Well, I'm going to do 10 times 10 first, which is 100. And then 3 times 2 is 6, which makes 600 different 4-digit numbers. Next one. Alan has forgotten his PIN code. He knows it begins with a 2, and the 4 digits make an odd number. How many different 4-digit numbers can he have? Okay, so 4 digits. He knows it begins with a 2, so there's only one possibility there. And he knows it's an odd number. So to be an odd number there, it could either be 1, 3, 5, 7, or 9. So there's 5 different possibilities there. So what about the other 2? So let's check if there's anything else. He knows it begins with a 2 and the 4 digits make an odd number. How many different 4-digit numbers? So these could be anything between 0 and 9. So 10 ways, 10 ways. And the product rule says times them together. 1 times 10 times 10 times 5. 10 times 100. 100 times 1 is 100. Times 5 is 500 different PIN numbers. Next one. Toby picks a 4-digit number greater than 6,999. And it's a multiple of 5. How many different numbers could he have picked? Okay, so it's 4 digits. You know the end one has to be 0 or 5, which means there are 2 different ways. And then the first digit, well, it's got to be greater than 6,999. Well, what possibilities are there of this number? It can be 7, it can be 8, or it can be 9. So there's 3 different ways you can have that first one. Now it can't be 6 because it says greater than. So 7, 8 or 9 there. What could be there? Well, anything between 0 and 9, so there's 10 different ways. That could also be 10 different ways. So 3 ways for the first one, 10 ways for the second one, 10 ways for the third one, and 2 for the last one. 10 tens are 100, 3 twos are 6, 600. Okay, and finally, now a flower shop sells 13 different bouquets and multiple vases. John says that there can be 140 different combinations of bouquet and vase. Is he correct? Why? Okay, so this is a typical GCSE type question, probably halfway into a higher paper, so around about a grade 7. So 13 different ways or different bouquets, times something. It says you don't know how many vases there are, and that has to equal 140. So what can you tell me about this number? What does it have to be? Well, it has to be a whole number. That has to be a whole number. So could he have 140? Well, you've got to do, to get this number, do the inverse, do 140 divided by 13. And if that is a whole number, then yes, he's correct. If it's not a whole number, then it's incorrect. 13 into 1 doesn't go. 13 into 14 goes once, remainder 1. 13 into 10 doesn't go. I've got to put some decimals down. 13 into 10 doesn't go. 13 into 100, well, that would be a decimal answer. And therefore, John is wrong, as number of vases must be a whole number, and 140 divided by 13 is not whole. Okay.